there's a way to make an entrance.
This is my destiny.
It was now a conspiracy of witches.
The Space Shuttle was designed as a cost-effective way of making travel to low Earth orbit routine. But the promise of cheap and easy access to space had unexpected consequences. During the 1960s, while NASA was striving to reach the moon, a feasibility study was carried out into a space plane that could be reused. Politicians were wincing at the costs involved in giant boosters that could only be used once. A craft that could take off like a rocket and return to the ground landing like a plane was touted as an economical alternative to disposable rockets. Concepts for a space plane had been around since the 1950s, but most of these had been little more than drawings backed up by a modest set of calculations. In the early months of 1972, a formal agreement was signed and NASA began work on a reusable space launch system that became known as the Space Shuttle. A fleet of 4 shuttles was planned, and they would all be named after famous ships. However, an extra shuttle to be used as a test craft was completed first. It was to be named the Constitution, after the famous US naval frigate. But fans of the TV show Star Trek petitioned the government to call it the Enterprise after the fictitious spaceship. As it rolled out from the plant in Palmdale, California, Star Trek fans were there in force. Fortunately, there had been several real ships named the Enterprise, so the administration relented and the new name stuck. Compared to the space capsules in which astronauts had previously returned to Earth, the new machine was huge and testing presented huge problems. NASA modified 2 747s to carry the Enterprise to varying altitudes for a series of approach and landing tests. With no engines, it had to glide to a landing, but gliders are light with long wings, and the shuttle was heavy with only stubby wings. It would hit the runway at incredibly high speed. The Enterprise made 5 non-captive flights, spending a total of just 19 minutes in the air. When Columbia, the first space-worthy shuttle, left the factory, big claims were being made for the new system. It would drastically reduce launch costs, and there would be a new mission every week. But there were critics that felt this was far too optimistic. Veteran astronaut John Young would be commander on the first shuttle mission. His pilot was rookie astronaut Bob Crippen. This was the first time a completely new launch system had been tested with a crew on board. Young was instrumental in convincing NASA that Columbia's first flight should not be a test of the very risky abort manoeuvre that required the shuttle to flip and to return to the Kennedy landing strip. Columbia blasted off on its maiden voyage in April 1981. It had been almost 6 years since an American had flown in space.
Columbia, Houston, you guys did so good, we're going to let you stay up there for a couple of days. Your gopher on orbit.
Columbia's first flight and the subsequent 3 missions were all designed to test the orbiter in space. Modifications will be carried out based on what was learned during these flights. The crew reported that insulating tiles on an engine pod had dislodged. The craft was covered in thermal tiles to protect it during the heat of re-entry. Problems with tiles would be an ongoing issue. Columbia returned to a safe landing and, though this first shuttle mission was a success, the orbiter had extensive tile damage and one of the undercarriage doors had buckled. Shock waves at launch were responsible for some of the damage, and the pad would be modified. But clearly the tiles were a vulnerable part of the design, and preparing the orbiter for reuse would take longer than expected. A new method for attaching the tiles was introduced, and engineers were confident other difficulties could be overcome. It took 103 days for NASA to prepare the spacecraft for its second flight. This would be the last flight with the large external fuel tank painted white, saving 272 kilograms. This time the commander was Joe Engel, with Dick Trugley as his pilot. The 4 shuttle test flights all had 2-man crews. Vital components in the new space transportation system were the 2 solid rocket boosters. The Shuttle program marked the first use of solid-fueled rockets for human spaceflight. Unlike the liquid-fueled main engines, these boosters could be stored with a full propellant load. But once they were alight, they could not be controlled. They burned until their fuel was exhausted. They were then jettisoned. And, just like the Shuttle, these boosters were designed for reuse. Waiting off the coast of Florida, recovery ships tracked their path back to the ocean. They fell from a height of 67 kilometres, with parachutes deploying at 4 kilometres. The recovery team collected the parachutes, pumped out the water, and towed them back to NASA for refurbishment. After Columbia's second flight, NASA discovered an O-ring designed to seal the booster's individual sections was partially burned through. Extensive testing of the solid fuel booster with intentionally damaged O-rings did not lead to failure, and NASA concluded that the safety factor for this component was large enough. The remaining 2 launches in the Shuttle test program saw the space transportation system take on a familiar look, with a large external tank remaining unpainted. Although the system was continually improved, this was the last change to its appearance. These test flights verified the shuttle's ability to cope with on-orbit thermal stress. and allowed the crew to gain experience with the robot arm. But there was also a secret military aspect to one of these missions that sat awkwardly with the civilian space agency. Modifications to NASA's original design had been made to accommodate military payloads. After Columbia's successful return from its fourth mission on July the 4th, 1982, the spacecraft was declared operational. This meant it could start earning its keep, and NASA had big plans for its new launch system. But some were arguing that things were happening too fast. New aircraft had to accumulate thousands of safe flights before earning operational status. Over the next 3 years, Challenger, Discovery and Atlantis entered service, with the new shuttle fleet's primary objective being the deployment of commercial satellites. However, launches were nowhere near approaching the 1 per week figure claimed during the shuttle's design phase. An orbiter could carry 3 standard-sized communications satellites. The shuttle fleet began a series of commercial satellite deployments. And when faulty boosters left some expensive satellites in low Earth orbit, new satellite rescue missions were scheduled, and a completely new capability became available. The SolarMax satellite, launched in 1980, had lost its attitude control. This left it unable to continue its study of solar flares. But astronauts had been training for a unique repair mission. Nothing like it had been attempted, but NASA was keen to develop the new techniques that the shuttle system was making possible. A completely new device that allowed astronauts to fly freely had been built. NASA had plans for a space station that would require complex construction techniques, and the manned manoeuvring unit was seen as an important new tool for astronauts to master. The repair of SolarMax was its first proper task. However, capture of SolarMax did not go smoothly, with mission specialist George Nelson inadvertently imparting unwanted tumbling to the satellite. The spin was stabilised by ground controllers, and the next day, using the robot arm, SolarMax was grabbed and brought into the payload bay. Several instruments had failed, and it took 2 mission specialists 2 separate spacewalks to complete the intricate repair. The team was discovering that an astronaut mounted on the end of the robotic arm could move with great precision. Though the astronauts who flew it said the MMU responded well to manual control, more practice was needed before it could equal the accuracy of the robotic arm. The repair mission had been so successful that new Earth-orbiting satellites would now be redesigned for ease of maintenance. Though the new space transportation system was taking a long time to refurbish between flights, NASA was scheduling future missions at a greater frequency. The space agency was pioneering new procedures, and the shuttle's future looked bright. In 1984, there were 5 shuttle missions. In 1985, with Atlantis completing the shuttle fleet, this increased to 9 flights. The overwhelming majority of shuttle flights at this time involved the deployment of satellites, but there were some missions, like the Space Lab, that were dedicated to science, specifically the study of weightlessness on the human body. This saw NASA entering into a partnership with the European Space Agency. Space Lab was carried within the shuttle's payload bay, but NASA was aware that the Soviet space program was planning the launch of an orbiting space station. The construction of a space station had been a prime design consideration with the shuttle, and NASA had begun planning its own space station, but money for this project was not materialising. In January 1986, a crew of 7 was preparing for the launch of Challenger. Although Cape Canaveral in Florida has a generally warm climate, conditions leading up to the launch had been frigid. Launch facilities had frozen during the night, but NASA was keen to proceed, and though some voices were urging caution, they were overruled. The crew was to deploy a data and relay tracking satellite. But one of the mission's specialists was schoolteacher Krista McAuliffe.
We have main engine start, 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
NASA saw this as an opportunity to rekindle enthusiasm for the space program and to illustrate how safe and routine space flight had become.
Program confirmed. Challenger now heading downrange.
Krista McAuliffe's parents were at the Kennedy Space Center to watch the launch. As Challenger climbed toward orbit, a rubber O-ring designed to provide a seal between the lower segments of the solid fuel booster began leaking flame.
Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up.
73 seconds after launch, the inevitable happened.
Nautical miles, downrange distance 7 nautical miles.
The solid fuel boosters flew on aimlessly, and the disaster continued to unfold live on television.
Obviously a major malfunction.
A comprehensive inquiry determined that the extreme cold had caused an O-ring to fail. It led to a redesign of the boosters. The inquiry also determined that NASA management had a tendency to exaggerate reliability to the point of fantasy. Before the next shuttle could fly, every aspect of the space transportation system was scrutinized. New safety procedures were instituted as well. It was 33 months before Discovery was rolled to the launch pad in September 1988. From this point, the shuttle's range of duties had changed. The crew had a new safety regimen, and their flight suits had been modified. And significantly, there would be no more commercial satellite deployments. On the return to space mission, Discovery's major task was the launch of NASA's own tracking and data relay satellite, a replacement for the one lost in the Challenger disaster. Work on a replacement shuttle, Endeavour, was started, but even with a shuttle fleet back to full strength, the frequency of missions would never be as great as before the Challenger disaster.
Copy, liftoff.
When shuttle flights resumed in 1988, its newly restricted duties blew a hole in NASA's business plan. The space agency still had ambitious scientific objectives, but fees from commercial satellite deployments would no longer flow. Major projects like the orbiting space telescope and what was now known as Space Station Freedom would have to be funded by the government.
1 minute, 30 seconds into the flight, all 3 auxiliary power units that provide hydraulic power to the orbiter.
While the shuttle was grounded, the Soviet Union had started assembling Mir, a space station that would serve as an orbiting laboratory. To NASA, this was good news. Cold War antipathy that had driven the race to the moon still existed, and Congress, not wanting communists to be ahead in anything, began allocating funds for design concepts for Space Station Freedom. Computer-generated vision of Space Station Freedom was produced, but not much else. the unthinkable happened. The Soviet Union collapsed, and, with the Cold War at an end, US politicians stopped funding space station freedom. In 1989, Atlantis deployed the Magellan probe, which left Earth and successfully went into orbit around Venus. It was the first interplanetary probe to be launched from a space shuttle. Because Venus is shrouded in heavy cloud, its surface remained a mystery. Magellan used radar to map the planet, revealing unique surface features. Magellan had marked NASA's return to big science, and the shuttle had been an important part in the process. But a new project that would be impossible without the space shuttle was in train, and astronomers were very excited. Work on an optical telescope that would orbit above the distorting effect of the Earth's atmosphere had started in 1979, but delays in its construction had led to delays in its launch date. It became known as the Hubble Space Telescope, and just one of its unique design features was the hinged protecting panels that had door handles. It was designed to be maintained in space, and only a space shuttle could do that. April 1990, and the astronomy world held its breath.
Liftoff confirmed.
Finally, the most ambitious, most expensive telescope ever built was on its way to space, and the scientific breakthroughs from such a clear view of the cosmos were expected to be huge.
Sees a roll.
Discovery had a crew of 5, including pilot Charles Bolden, who went on to become the administrator of NASA. Discovery climbed to its highest orbit to date, 612 kilometres. The higher orbit would ensure Hubble's longevity. Apart from a small problem with its solar panels, the deployment of the telescope went smoothly. NASA and its European partners were hoping it would remain in service for at least 15 years. The first pictures from Hubble were blurred, and ground staff started adjustments to fine-tune the instrument. But in weeks it was apparent that there was a flaw in the primary mirror. Hubble became a laughingstock, the most expensive piece of space junk ever. Soon, plans for an elaborate mission to fix Hubble were underway, and the space shuttle was an essential part of a mission designed to turn a disaster into a triumph. But nobody was really sure if it would work, or even if it was possible.